We've spent a lot of time this semester converting units, and this will be our last section. But there are quite a few different units that we have to convert in this one section. First, let's start with temperature. We're going to be talking about the Fahrenheit and the Celsius scale. Now, these formulas you don't have to memorize. They're going to be given to you on the exam, but we do need to go over how to use them. A little bit about the Fahrenheit and Celsius scales. The Fahrenheit scale is what we use over here in the U.S., and it splits our temperatures into 180 even parts. The Celsius scale was invented later, and it breaks temperatures into 100 even parts. So if you take 180 divided by 100 and reduce it down, it gives you this 9/5. That's the ratio of Fahrenheit to Celsius. The 32 is from water freezing. In the Fahrenheit scale, we say water freezes at 32 degrees. In the Celsius scale, we say water freezes at 0. So that's a difference of 32 degrees. That's why we have this 9/5 and 32. And down here, you'll see their inverses, the 5/9 and the -32. All right, so for some examples, I'm going to give you Fahrenheit, and you need to find the Celsius. So that means we need to plug into the formula that has Celsius as the answer. Celsius equals all this stuff over here. And I'm going to plug 0 in where I see F. So I plug a 0 in for F. I am going to follow my order of operations and do what's inside the parentheses first. 0 minus 32 gives me this -32. Multiply that by 5/9, and I get a nasty decimal. And the directions I'm going to have are I'm going to round to the nearest degree. So -17.777 is going to round to -18. Let's use the other formula now. I want my answer in Fahrenheit, so I'm going to look for the formula that has Fahrenheit as the answer. I'm going to plug in 38 degrees for Celsius. Now I just have 9/5 times 38 and then add the 32. That's going to give me 100.4. Again, I'm going to round to the nearest degree. So I'm going to round to 100. Next, let's convert mass. Remember, mass and weight are not exactly the same thing. Weight measures our gravitational pull, so our weight changes if we were to go to the moon. Our mass does not. The mass measures the amount of matter that we have. One new thing with mass, we haven't seen a ton yet, and we're just going to define a ton is 1 million grams. And our mass we're going to measure in grams. To kind of give you an idea what a gram is like, you can think about a gram being comparable to an ounce. They are not the same thing, but if you were to measure something in ounces, something small, then we would measure in grams. If we were to measure something like our weight, our body weight, we would measure in pounds. So that would be a sort of equivalent to kilograms. They are not the same thing, but just those are the units that we can imagine measuring in the metric system. We're going to use our regular metric scale with gram being in the middle instead of meters. Everything else is the same. Kilograms, hectograms, decagrams, grams, decigrams, centigrams, and milligrams. Again, the only new one is a ton. We have a ton being defined as 1 million grams. The rest of our converting is going to work exactly the same. So I have kilograms. I'm going to go to grams. So I'm going from big to small. So I'm going to multiply. Take my kilograms. I'm going to multiply by 1,000. Because there are 10, 100, 1,000 grams in a kilogram. And I'm going to get my answer of 6,836,000 grams. Next, I'm going to take these tons and go to grams. Again, I'm going from big to small. So I'm going to multiply 5.7 tons. Now I just need to remember that a ton is 1 million grams. So I'm going to get 5,700,000 grams.